Hi everybody, I'm Abdul Ragab and this is VLSI and V question and answer, and the contents are about these topics STA and CDC and ASIC and variable condition design, and this topic today is about static time analysis. The question today, it gives you that design and asks you how can this variation can be resolved. As you can see, there is two paths. Each path has variation. The first path has setup variation and second path has hold variation. As I mentioned in the video title, which is about how we can solve the timing variation using skew. We're gonna solve this variation using skew, but we need to know first there's two types of skew: useful skew, harmful skew. Useful skew, the skew which is purposely added in the design to meet the timing. If we take a look at our design, we're gonna find out it combines of two paths. First path has setup variation with negative slack equal to -2 nanoseconds, and second path has hold variation with negative slack equal to -1 nanosecond. And as I had mentioned before, for setup equations or for setup variation, we can solve setup variation by adding positive skew or increase positive skew or decrease negative skew, but for hold we're gonna need to add negative skew or increase negative skew or decrease positive skew. So let's take the first path separately and see what we can do to solve this variation. For this path, it has setup variation with negative slack equal to -2 nanoseconds. We can calculate the slack from equation, which is equal to arrival time minus required time, equal to -2 nanoseconds. I had mentioned before that to solve setup variation, we're gonna use positive skew, but now we need to know what's the value of positive skew need to be added to design to solve setup variation. We're gonna find out that the skew need to solve this variation equal to 2 nanoseconds by applying this skew to the equation. The new setup slack will be equal to 0 nanosecond. So this value helps me to get rid of the setup variation. But as I mentioned before, positive skew has harmful effect on hold time. So let's check if this positive skew can cause any hold variation. As you can see here, hold slack equal to positive 3 nanoseconds. We can solve the hold slack from the equation, which is equal to required time minus arrival time, and by apply this positive skew to the equation, we're gonna find out that the new positive hold slack equal to 1 nanosecond. So the hold satisfied and setup satisfied with the new value of positive skew. For the second path, which has holds variation with negative slack equal to -1 nanoseconds, we can calculate the slack from the equation, which is equal to -1 nanoseconds. And I had mentioned before that to solve hold variation, we're gonna need to add negative skew. But what's the value of skew? We need to add it to get rid of this hold variation. We're gonna try to add -2 nanoseconds and apply this values equation. We're gonna find out that the new value of hold slack will be equal to 1 nanosecond. Let's see this negative skew maybe have harmful effect on the setup time. Let's see if this negative skew has any effect on setup time. As you can see here, setup slack equal to positive 4 nanoseconds. We can calculate it from the equation, and by applying the negative skew to the equation, we're gonna find out that the new value of setup slack equal to 2 nanoseconds. So the slack satisfied and also satisfied by using this new value of negative skew. You can see that this value negative skew will be added before the launch flop. I use this buffer as the skew with delay 2 nanoseconds. As you can see, this buffer acts as positive skew for first pass, which is on the way of the capture flop, and act as negative skew for second pass, which is in the way of the launch flop. So these two solve setup variation for the first pass and solve hold variation for the second pass, and doesn't cause any harmful effect and doesn't affect the hold time of the first pass or the setup time in second pass. And second type of skew is harmful skew. harm of skew, which is kind of skew, we can add it to failing paths, fixing time variation, but it can cause variations. It solve variation but cause another variation. As you can see in the sign, if we change the values of this buffer to be 5 nanoseconds, we're gonna find out that for the first pass it solves the setup variation, but it leads to hold variation with negative slack equal to negative 2 nanoseconds. And for second pass, it helps me to solve hold variation, but it causes setup variation with negative slack equal to minus 1 nanoseconds. So you need to be careful about the value of skew need to be added and the type of skew, positive skew, negative skew, to solve these variations. And thank you